All right. So, questions? What kind of, go ahead. Ooh. Remember I said that you guys are going to have 2 questions on the lab work? I'm guessing that's one of them, and then there is a second one as well. Oops. Dang it. Wrong thing. Do you guys figure out what the second question is? Have we figured out the second question? No? Okay. Number 3. So for the ones that hadn't opened up the lab work yet, thanks CJ for it, because it's actually caught. So, and I knew that there was going to be 2 questions. That's why I said it on Monday for that reason. So, number 3, a painter can finish. So, number 3 is called a work problem. So, let's talk about the work problem. So, as I said before, when we do word problems, we want to read a section, write something down, right? Read a section, write something down. So here we go. Ready? A painter can finish painting a house in 7 hours. Write something down. A painter can finish painting a house in 7 hours. Write something down. A painter can finish painting a house in 7 hours. Her assistant takes 9 hours to finish the same job. Write something down. Her assistant takes 9 hours to finish the same job. Her assistant takes 9 hours to finish the same job. How long would it take for them to complete the job that they were working together? Okay? So, how do I want to write this? We'll say the boss takes 7 hours. Assistant takes 9 hours. Question is, how long will it take them if they work together? So the 7 hours, so the way we do work problem is this. So if it takes her 7 hours to do the job, how much of the house is painted in 1 hour? For the boss. But how much of the house would she finish in 1 hour? Huh? 1/7. Make sense? Does that make sense? Okay. So if it takes her 7 hours, so in 1 hour she'll only finish 1/7 of it, right? A seventh, a seventh, 7/7, then it's a complete hour, right? So it takes her, she does it in 1/7 of the house. The assistant takes how long? So how much of the house is he going to finish in 1 hour? 1/9. If they were to work together, question is, how much of the house would they finish in 1 hour as well? So this is how we work with work problems, right? We say how much of it will get done in 1 hour? How much will it get done in 1 hour? If they work together, how much will be done in 1 hour? Once we know how much they will get done in 1 hour, we know how many hours it would take. Does that make sense? And this is a rational equation, right? Get the sisters. Was one missing that the other's missing, right? Do I need to continue? I can. I don't mind. Do we know how to do this problem? Okay. So how do I get rid of fractions in a rational equation? The denominators have to be the same. So what's the 7 missing? Just the 9? So let me draw the sisters out. What do they have that I don't have? So she's missing a 9 and an x. If I do it to the bottom, I have to. This is why I talk about the sisters, for that reason. So this sister here says, what do they have that I don't have? Seven and what? X. If I do it to the bottom, I have to. All right. She's saying, what do they have that I don't have? A 7 and a 9. If I do it at the bottom, I got to do it to the top. Okay. So, is this denominator the same as this denominator? The same as this denominator? Yeah. And since this is an equation, then we can just rewrite the top. So if you guys notice that when I'm doing this, right, since exam 1, I've said the same thing. We've done these since exam 1. Am I right? We did it in exam 2 as well, and now we're doing it in exam 3. Right? And I warned you guys in exam 1 that we're going to do this over and over and over, right? And if you guys were to play the tapes back, I'm going to guess that every time we did this, I said the same thing over and over. True? Like, enough times where I think you guys can probably repeat exactly what I would say. Is that fair to say? Right? And this is the reason why I want you guys to rewrite those what we knows. And so that when you're on the exam, you're like saying the same thing, going, yep. What does this one have that these two don't have? What do they have that I don't have? What do they have that I don't have? What do they have that I don't have? Is the denominator the same? Right? Or sorry, what do they have that I don't have? What do they have that I don't have? Do it. And are the denominators the same? I can rewrite the top. Right? Because it's an equation. Now, if it wasn't an equation, then I got to keep the top. Do we know how to solve this? Now, here's the problem, though. Because most of the time, I want improper fraction. I want that as a fraction. But let me ask you this. If someone goes, hey, how long is it going to take you to paint this house? And they're like, 63 and 17th hour. You're like, what does that even mean? Right? This is probably one of the few times that I would actually don't mind a mixed fraction. So if I change this to a mixed fraction, what would it be? If it was a mixed fraction, what would it be? Huh? A number in front of a fraction, yes. Do we know how to do that? He said 3 and 12/17. How did he do that? Calculator. Here's the problem. I'm going to guess the reason why nobody had an answer is because they don't know how to use the calculator to get that. See, you're just looking at the calculator going, what do you mean? It's right there. All right, so If we did 63 divided by 17, I get that. Is that right? Oh, I'm sorry. It's supposed to be 16, isn't it? You're right. So it's not 12. Sorry. Well, maybe it is. I don't know. Let's see. Sorry. You're right. Thank you for bringing that up. So I get that. Is that right? The problem is that if I hit the fraction button on the far right, it's going to give me the same thing. So that doesn't help me, right? Are we okay there? Do you guys see the 3? Okay. So a couple of ways of doing this. We can either plug in the decimal and make it a fraction. Or, since I know it's 3 of them, so what I can do is say, okay, what's 3 times 16? It's 48. Everybody see that? So that means that if I take the 63 and minus the 48, I get 15. So it will be 3 and 15 sixteenths. Everybody understand? Now, I can always take that decimal, what is that? 0.9375 and change it to a fraction. Everybody see that? So I could do that if that's the case. Then I can get the fraction. Cool? So the follow-up question is going to be what? Since you guys are so good at it, what's the follow-up question going to be?
How long will it take them?
Well, no. What's the follow-up question going to be? What are you guys so good at on the lab work? Meaning I'm joking. Yeah, well, we're going to write down for the what we know. Is that fair? Okay. What was the first thing I talked about with word problems? Is that what I say? Write them down? But first what? Read apart. Write something down. Read apart. Write something down. Yes? Okay. From what we write down, we want to write an equation. And for work problems is 1 over A plus 1 over B equals 1 over C. Okay? We're going to be adding, subtracting, we're going to be doing a rational equation. So what are the steps of a rational equation? We got to get the denominators the same, sisters, right? Once the denominator is the same, because it's an equation, I can rewrite the top as my equation. Solve. Because it's a work problem, I ought to make this a mixed fraction, because if someone says it's going to take 3 hours and 15 sixteenths of a minute or an hour, you're going to know it's going to take almost 4 hours. Right? If it was 3 and 1/16, you'd be like, okay, so it's just going to take a little bit over 3 hours. Does that make sense? But the 63 over 16, you'd be like, huh? What do you mean? What does that even tell me? Okay? And that was said, what, around 1330-ish? So if you want to put that timestamp down, you can at least get to that. Now, this one here, number 5, says I is equal to NE over NR plus big R, and I have to get N by itself. Any ideas how we should go about doing that? We do have to move it around, but how are we going to move it around? Just start picking up and moving it? You go here, you go here, you go here. That's what we want to do, right? That's what we want to do. It's just going, let's just move it around. So a lot of times the complaint is this. These are all letters, right? So just so you guys know, the reason why they use lowercase r and a large case r is because those two are actually different numbers, right? Because I'm solving for n, that means n is the only thing that is really a variable. Everything else is just numbers. I is just a number, capital E is just a number, lowercase r is just a number, uppercase r is just a number, but all of those are different numbers. Is that fair? Okay. So let's do this. Because there's too many letters, that confuses you guys, which I understand. So let's do this. Let's change this up, and let's make up numbers for everything else. What does I look like as a number? Huh? Let's choose something besides 1. You're right, though. It does look like a 1. Let's choose something else that's not a 1. Any numbers. It looks like a 5? Okay, sure. How about capital E? Huh? 3? Okay, because it's like a backwards. How about lowercase r? Two. Okay, fair. And how about uppercase r? 4. Sure. Now, the part that I'm glad that you guys listened to is saying that all of those letters are all different numbers, right? And we're trying not to use 1. Okay? Now, what I want you guys to do is from here, tell me how to solve for n. What kind of problem is this? You mean this might be a rational equation? I believe that's what you just said. Is this a rational equation? That means I see fraction, I see equal sign, hence a rational equation. Does that make sense? Yes? So what we want to do is, remember what we said with the last problem, right? It's a rational equation. What do we do? Get the denominators the same. Okay. How do I make this denominator the same? What do I got to do with the 5? Awesome. Whoop. Whoop. Awesome. Okay, that sister's a little weird. What do they have that I don't have? 2n plus 4. If I do it to the bottom, I got a awesome. How about this one? We could do 1, yeah, sure. Are the denominators the same? Yes. So that means I can rewrite the top as my equation. Am I right? So again, same exact things I just said, right? Okay. From here, what would I do? Distribute, right? Multiply, distribute, all means the same thing. So here, I'm going to do something a little different here. Because you guys would say 10n plus 20. Is that right? I'm going to write it a little bit different. How about if I say 5 times 2n plus 5 times 4 equals 3n? Is that fair? Because that's still 10. That's still 20, right? The reason why I'm writing it this way because when I'm using letters, I can't actually multiply them, right? I can only put them next to each other, right? Just like the 5 and 2 and the 4 and 5. All right. So I'm still trying to get n by itself. So what should I do there? How do I get n by itself here? Huh? Ooh. Ooh. So if I move the 3, what is it going to become? Minus 3n. And what am I going to do with the 20? Am I going to leave it there? So here, let me do it this way. What do I do now? I got to move this over, right? Here, let me do a reminder here. Up here, didn't we get the x's on the same side, number on the other, right? So that I can combine the x's to the number so I can divide it off. Right? Make sense? So we're doing the same thing here. So we will have to subtract that 5 times 4, or 20, over to the other side. So I'm going to have this equal to negative 5 times 4. Now, typically, I can just subtract these, right? Because 10 minus 3 gives me 7. Is that right? Okay. But if these were letters, I wouldn't be able to subtract them. If I'm not able to subtract them, what else do you see there? Starts with G, ends with F, GCF. Can I factor out n out? So if I factor out n, wouldn't it be 5 times 2 minus 3 is equal to negative 5 times 4? And then what would I do to get n by itself? Okay, here, let me do it this way. So if I had 10n minus 3n plus 20 equals 0, then you go 10n minus 3n equals negative 20. So you have 7n equals to negative 20. How do I get n by itself? So if I divide by 7 here, what am I actually dividing here? The parentheses. So n is going to equal to that right there. Does that make sense? So when I talk you guys through it, does all of this make sense so far? Now, this is what I want you guys to do. You guys ready for this? I want you to follow exactly these steps. With this now. Exactly the same. Go for it. What did we do first? Great. Go get the denominators the same.
So
Without adding numbers. Using those letters. So we're now going to do it with letters, but we're going to follow the number example. Yeah. Yeah. Doesn't matter. You can put anything over 1. It's still the same. Equals to what?
What's that?
What is it equal to? Is it equal?
N.
E, yep. No, it's I over 1. Put anything over 1. What did I do next? So look over here. What did I do next? After I got the denominators the same, and I rewrote the top as my equation, what did I do after that? So I got the denominator the same, right? I rewrote the equation, the top. What did I do from here to here? Multiplied, or what's the other word? Distribute. Right? I distributed 5 through, didn't I? Right? Because I got a monomial times a binomial. So that means I got to distribute. Right? So go ahead and distribute. What's the next thing I did? Which is what we just said.
So what I do with I times 2.
Yeah. Well, wouldn't you this times this and this times this?
Yeah.
Okay, do that. So you're fine. I, N, and what? Plus. Yeah. And then what did we do? So you got to here. What did I go from here to here? What did I do with this? Yeah, because it has the n, right? So I want to get the n on one side and the numbers on the other. Yes. That's just 10. When you subtract this over, that should have been negative, right? Why do you have negative n?
Because I moved the n into the side to get it 10.
But here's the thing. You skipped a step.
Again?
Yeah. What were you supposed to move over? You missed something big. INR. Wait a minute. Why is this just R? Aren't you supposed to distribute this? Mm-hmm. Okay. What did we do from here to the next step? Because we can't subtract them, right? So what did we do instead? Yes. Pull the. So far, looks really good. What was the next step I did, though? Something's missing. You can't cancel those. Because remember, this is bound with the subtraction sign. So you can't eliminate someone from the family.
Is it supposed to be like this? Or like that only supposed to take the n or the whole thing?
That's together. So you have to take the whole thing over. Yeah. But then what do I do from there? You missed a negative somewhere.
Right there, right? Is it
Yeah, because you moved that over, you got to subtract it, right?
even when it's like in this form, it's still
Well, yeah. It's still a positive or negative. Because it's just numbers.
okay.
It's just numbers. So it's still going to move the same way. So if you subtract it from one side, you got to subtract it from the other. I think you're actually right. So my question is, did this example help? Yeah? So my whole thing is, anytime you get stuck with something like this, whatever you got to solve for, that becomes a letter. Everything else becomes numbers. Okay? And if it was to help you, then go with it. Write out the number form and then go, okay, let me transfer it over. And here's the cool part. You gave me numbers for I, E, lowercase r, uppercase r. Is that right? If I was to replace these numbers back to those letters, I should get exactly that. Does that make sense? What was 5? 5 was the I, right? So you should have negative I. What was 4? 4 was uppercase R. So capital, negative, capital I, capital R. Over capital I, the 2 was lowercase r, minus uppercase E. That should be my answer. All right? So if I was to do this, I would do exactly the same, right? So if I was to do this, I would move this up, put this over 1. This is needing an NR plus R. Rewrite the top. Distribute. Get all the n's on one side. Get the number on the other. GCF of n on the left side. divide off the parentheses. Does that make sense? Yeah? Questions? Yes? Cancel what? What?
So, why not that? I got, n outside the parentheses, capital I R minus E, and then the parentheses ended, and that was over, in the parentheses, capital I R minus capital E, parentheses, and then I got that on the other side. How come the whatever was inside the parentheses didn't cancel the third one?
Is that right? These two did cancel out. That's why I have the n left. Are you wondering if these two should cancel?
I was wondering, like, since, the denominator on the second fraction was the same thing, how come that didn't cancel?
Like these two?
No, like, the denominator on that, how come it didn't cancel as well?
It will have to cancel with something up top.
Oh, okay.
Right? Just like if it was numbers, right? If I had, what was this? It was 7n equals negative 20. I would divide by 7. Right? Unless there are factors that are alike that can reduce, then I would reduce it. Right? So if something went into 20 and 7, then I could reduce that. So over here, because there's no factors that are the same, that's why I can't reduce it. Okay? I can't cancel this I out because this is a binomial. It's bound by that negative sign, or it's a subtraction sign, so I can't eliminate them. Okay? Cool? Any other questions? Okay. I need you guys to do that problem then. This is an extension of our last notes. I'll be back. So you have a rational equation. So what do you need?
So all the denominators are the same.
So you did it here, but why didn't you do it to the
I
top?
haven't done that.
Okay. Yeah. So yeah, you want all the denominators the same. Yep. 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 Why didn't you factor that? Isn't that factorable? You're gonna make your job a lot harder if you do that. A lot harder. So just like what we've done so far, right? We've done two rational equations, right? So what you're doing here is going to be once you factor, right? So now you're going to bring in the sisters and say, what do they have that I don't have? For all three of them. Oh, we skipped the first step apparently. What is step one in rational equations? Huh? Before that. What has been the first step every single day so far in this unit? Factor. Now, if there's nothing to factor, that's different. But are there certain things to factor? Oh, there is. Son of a gun. How'd you get that? You can't follow this.
I think I did an extra step right here that threw me off. I think this is the problem.
No, you have three terms here. That means all three denominators have to be the same. And you skip the first step also, which was factor first. So you got to always factor first. You didn't factor, sir. Yup. Nice. Now we solve. Yes. That looks. Why does it have both of these? See, this is why I always show what I would do to the bottom, I do to the top, right? So that I don't get confused. And if you did that, then you're gonna notice that it's not both of these, is it?
Yeah.
Because you only multiply this, so that's why that wouldn't be there. That's why I do it. Whatever I do to the top, I do to the bottom. Correct. Well, you didn't do it to this one either.
Yeah.
No, well, that's not factoring, right? We don't need to factor in just numbers. Yep. So you saw it? Oh. Okay. Uh-huh. You see the square term equals. When was the last time you factored anything with a negative x squared, sir? Like, huh? Well, here's the thing. Why not move everything to that side instead? You thought it was easier because, oh, you know what? Because there's only two terms, there's three terms here. Let's move everything. Always keep the x squared positive. So move everything. So just erase all of this and move everything to the right instead of to the left. Is that fair? Does this really need that? Does this number need that? Now, okay, before I do that, here, let's look at this. Are all three denominators the same? Mm-hmm. They are? This has 1 and then these two. This has 1 and these two. These two are the same. But this has 1, 2, 3, and the 1. Sorry, the same? No. Because that one didn't need that, right? Does that make sense?
Sorry.
You're fine. You're fine. If that took my finger off, then that's a different story. Why are you canceling out for? Is this denominator the same as this denominator? The same as this denominator?
Oops, I accidentally wrote it wrong. So,
Wait a minute.
oh yeah, it was an eagle.
You screwed up somewhere. Wait, you got the denominator the same, right?
Yeah.
So aren't we supposed to just rewrite the top? And you're still missing this. Give me the pen. Whatever you do to the bottom, you do it to the top, right? Now that the denominator is the same, I just rewrite this top as my equation. Come on now. What's the purpose of... Now, I agree with you. Now, what you did before, right? I would agree with you if you were doing that. So why are we drawing on the top when we're just going to write what's on top anyways, right? And what's the purpose of that? We rewrite it because it is there, because we got the denominators the same. What are you doing?
Yeah.
You factored in correctly. All right. You guys make me. You make things interesting. Okay. First of all, so am I right by saying that when I do these problems, I do it this way? What times what gives you 16? Guys, this is why I do what I do. I'm not trying to add extra steps to you guys. I'm trying to make things simpler. But you guys don't see it that way. I understand. And the thing for me is this, is that what I notice is that you guys want to find shortcuts before even going through the process. So let me ask you this. If someone wants to be with you, is it okay for them to start taking shortcuts from the get-go? You want them to go through the process, don't you? You want them to ask you out. You want them to woo you. You want them to take you out. Is that true? So what's the purpose of the process if you want shortcuts? Does that make sense though? And I'm not just talking to you because we all do it. Now, after you go through the process, then if you start seeing the shortcuts that you can take because you understand, then you can go ahead and take those shortcuts. So for example, now that I'm older, now that I've done the process, I can say, you know what? Just because I ask a girl out doesn't mean I have to bring her flowers every single time. Because some girls don't like flowers. Does that make sense? They accept it because it's a nice gesture, but they don't like flowers. They have seasonal allergies, so those flowers just going to make them sneeze and get a rash and all that stuff, right? But some of the process needs to stay. But we got to go through the process first. This is the reason why I say the same thing over and over. Exactly same thing. Because I don't want to confuse you guys on saying something different one time, because then it's going to be confusing, right? And every single time I factor a binomial, that's the difference of two squares, I always show this, don't I? And every single time we talk about factoring, we should always show those steps, shouldn't we? And I said this before. Every time we say factoring, so every single time you write down first step and say factor, all of that should show up. I said this last week as well. Only one or two of you guys actually wrote that out. Everybody else totally just skipped it. Again, I said it last week before the lab work was due that if we say factor, all of that should be written out. Only one or two of you guys actually wrote it out. Okay? Now, so what I have here is this. And you guys put this over 1. Awesome. So I bring in the sisters. What do they have that I don't have? She pretty much has everything. Some of you guys want to do 1, that's certainly fine, because the 1 doesn't really do much, right? What do they have that I don't have? Whatever I do to the bottom, I have to do to the top. What do they have that I don't have? Whatever I do to the bottom, I got to do to the top. Like some of you guys think that's too much writing. But here's the bottom line, is that when I notice that the denominators are the same, I rewrite the top, so I want those to be there. And if you guys want the times 1 there, that's certainly fine too. Right? The denominator is the same. I have the same in all 3 of those. How do we do there? But it's not. It's multiplying by 1. So instead of this.
I put that, but I put a 1 in front of it as well.
Okay, so what's 1 times this times this? Same, right? That's okay. You can leave the 1. Okay. So what do I do here? What do I do with this? Double distribute. But here's the thing, guys. Guess what? We should already know what that equals to, shouldn't we? Because we just did that here, which was the result of that, wasn't it? So we should already know that this is going to be and what do I do over here? Distribute. I see a square term and an equal sign, don't I? You guys all see a square term? Do you guys all see an equal sign? What should I be thinking of? Quadratic equation, right? Where I might have to do the AC method. So I got to bring everything to one side. So guys, here's what I want you guys to look at. Let me use a different color here. If I looked at this right here and this right here, right? That's the square term. When I factor, have I ever factored anything that was a negative x squared? No. So in other words, I want to protect this x squared to make sure it's positive. So is it better for me to move everything to the right or move everything to the left? So if I moved left, I would subtract the 2x squared, right? If I subtract 2 here, wouldn't that become negative? So wouldn't it be better for me to move everything to the right? Right? So, subtract x squared, subtract x squared. What's 64 minus 16? 48, thank you. Bless you. Now, guys, remember we talked about factor on top. We should be writing those 4 things, right? GCF, 4 terms, 3 terms, 2 terms. Is that right? I don't need to rewrite it again in the same problem. Okay? But what do we have here? We have factoring, don't we? What's A times C? B? What are my 2 numbers? Is that what I have? Can I do this the easy way? I can only do it the easy way if A is equal to 1. Right? Is A equal to 1? Yeah. Can I use both answers? ¿Por qué? If I look here, what does 4 make this? A 0. 4 will make that a 0 as well. So if I look, remember I'm not calling for restrictions, but restrictions are going to come and bust you in the mouth if you don't pay attention to it. Sorry guys, had to take care of that because someone is coming in this room and doing things that are not supposed to be done. All right. So don't forget that we'll have to reject this. And why? Because of the restrictions. And it's a restriction because the 4 would actually make a denominator 0, which makes the fraction undefined. Therefore, that equation would never even exist. So therefore, since this is my only answer, then that would be my answer. And the negative 12 won't make any denominators 0, so I'm good. Make sense? Box the wrong thing. Any other questions? Nothing? No questions at all. We're good. Any other questions on the lab work? Number 7 is easier than you think. So it says this. It says P of x equals 3x squared minus 9x plus 1, semicolon, negative 5. Okay? So let me read the direction. It says, for the given polynomial, P of x, and the given c. So if you look at this, I said, for the given P of x and c, what do you think? C is the negative 5. Awesome. It wants you to find P of C. So that means you just have to find P of negative 5, right? And that's it. So that's why I was saying it's not as hard as you guys think. Well, but I said that on Monday, and you weren't here. So therefore, it makes sense. Does that make sense for everybody else? All right? So that's all number 7 was. What about number 8? So number 8. So on Monday, what we talked about was that how we divide monomials is different by how we divide by binomials or larger. If it's binomial or larger, we have to do long division. You'll have to go back to the video for that one. Monomial, however, we've done before because I think it was in one of those optional lab works. I think it was 4C, which we kind of reviewed it. So what we would do is we would split it up to separate fractions. Same denominator. And then we're going to reduce each fraction individually, and that would be my answer. Cool? But here's the thing. This is the reason why I record. Right? I don't want to sit here and go, well, maybe you should just make sure you show up to what, but poop. Life happens. Makes sense, right? I can't go, well, you should have gone to a car accident, right? Like, life happens. This is why I record things, so that when you're up to it, you can go, okay, I can review it. Okay? But are you okay? Yeah. Okay. That's all that matters. Because cars can be replaced. People can't. All right? I'm glad that you're okay. Any other questions? Nada. Nothing at all. Nothing at all? That's it? Okay, next question. What questions do you have on the review? Because you didn't know the review opened up, right? It was open yesterday, last night at 6 p.m. Did we look at it? You did? This is the day that you guys can ask any questions on the review. I will answer them. Next Monday, however, not so much. Yes. So again, I'm not gonna expect that from what we know. But if you happen to find it, awesome, right? Because it's always funny because when I ask for it, it's like it's extra work, right? Because I pounded on it on the first day, and then after that I was like, that's silent because it does now. It actually matters. So yeah, it will always be the same as the other steps, where before our first step was factor, second step was find restrictions. After, well, it doesn't have to. Doesn't have to. Once you factor everything, that's when you should get it. Okay? Because we definitely don't want to make sure we find restrictions before things get canceled out. And if we found new restrictions, like in dividing, we're just adding on to it. We're not taking some out because there's a new denominator. We're finding new ones because we're adding on to it. Okay? Any other questions? So here's what I'm going to suggest to you guys. Number one, get the lab work done, hand it in. If you can get it done tonight, get it done tonight, hand it in. Someone actually told me yesterday that they had it done the day before, and they're like, I have all day tomorrow to submit it. Came home from work going, yeah, I got to remember to submit that lab work. Went and took a shower. Apparently showered off that memory of submitting it. And an hour after was due, and she had it done. So hopefully you guys get it done, hand it in by tonight, so that once you get the lab work done, I want you to clear off your desk, grab some scrap paper, take the quiz. No help. Just your calculator and scrap paper. See how you do. Okay? And in fact, someone also admitted to me that the best cheat sheet ever is working for them. Just saying. I haven't yet lied to you this semester. I'm not going to start lying to you. But I also cannot force you to do those things. You're going to have to be the one that executes it. Okay? Other than that, then, ladies and gentlemen, please have a wonderful, blessed weekend. Please be safe. Love you guys. See you guys on Monday. Later.